What's up, guys? Welcome to another video. And on this video, we're going to be doing something exciting, interesting. We'll be looking beyond theories. In the first video I made in this series, I talked about diving deep into the mathematical foundations in ML, and honestly, it was boring. Why was it boring? Because they were taught by mathematicians and not programmers. So it was more theory, theory, theory. So in this episode, we'll be looking at operations in matrices, especially addition and subtraction. So there are a lot of operations in matrices. And if you don't know what matrices are, I suggest you watch the previous video. The link to it will be attached right above you. So there are different operations in matrices. The major ones are addition, subtraction, scalar multiplication, and multiplication. There are other tiny operations in matrices like transposition of a matrix, transposing a matrix. You have the inversing of a matrix, you have the finding the determinant of a matrix. All these are operations in matrices, and we'll be looking at them sequentially. But in this episode, we are starting with the simplest and the most common operations in matrices, which is addition and subtraction. So let's dive in. 1 plus 1 is equal to 2, and 2 plus 3 is equal to 5. Well, that's just a normal addition and subtraction. What about in matrices? You see, we have two matrices here. Well, this is precisely a square matrix. You see how these two matrices add to form a new matrices. But how does it even work? Well, it's just like normal addition with a little twist on top of it. 1 and 5 adds to forget the new element for the new result matrix. 6. 2 and 6 add to give us 8, 3 and 7 add to give us 10, 4 and 8 is added to give us 12. So you can see that there is a pattern. And if you haven't noticed it, the pattern is simple. Corresponding matrices, corresponding elements in both matrices join together to form new elements for the new matrix. Wait, that's not all. There is another twist. They both two matrices, 1, 2, 4, 3, 4, 5, wants to add to 5, 6, 7, 8. Well, you can see that this matrix on the left has the first matrix has 2 rows and 3 columns, while the second matrix has 2 rows and 2 columns. But they can't be added. Why? Because in matrices, in matrix addition, for an addition to be successful, for an addition to take place, the both matrices involved must have the same dimensions. Dimensions is simply the rows and columns of a matrix. In the first example, the both matrices had the same dimensions, so it was easy to add the elements together because the elements correspond. But here it doesn't, so the matrix, the addition can't even take place. That brings us to the two ground rules for matrix additions. The first one is all matrices involved must have the same dimensions. Oh, I know I've said it like 3 times. All matrices involved in the addition must have the same dimensions, and corresponding elements must add to form the new element for the result matrix, just like we had in the first example. Now, enough talking and enough theory. Let's get down to the practical. So we are going to be adding matrices in Python, and I'll show you 2 ways to do that. Now we are going to be implementing a matrix in Python, and not just that, we'll be adding 2 matrices in Python. Let's dive in. So first off, we'll create a Python file, main.py, and also the code to this will be in the GitHub repo. I'll attach the link to the repo in the video description. Be sure to check it out. So let's use a class. I love object oriented programming because it has a way of making your codes more structured, the system more structured, and your programs more modular. So we'll first create a class called Matrix and give it the initialization function in it. So, okay, self, and we'll take an argument called Matrix, people, which we'll use to pass in a matrix at instance. Now, the thing about matrices is that they are very simple to implement. A matrix is just like a nested list, something like this. This is a matrix. Let me call it list X. So this is a matrix. 1, 2, 3, 4. So this is just a matrix. But why are we even stressing ourselves to create this class specifically for matrices? Well, we want to be able to manage things easily. So creating this class, we can easily call functions on that array, that nested array, which represents a matrix, something like the add function, the subtract function, the multiplication function, even the scalar multiplication function, even transposition and the rest of them. So making it object oriented makes it easier for us to manage. So we'll define a property called matrix and give it assign it the value of the matrix argument. Then next off is we are going to create a function for insert, for adding rows. So call it add row and self um, row, and the position, I'll set the position equal to false. That's because if the person fails to specify a position, it just adds the row at the end of the matrix. So if not position, self dot matrix dot append row and return. But if a position was given, self dot matrix dot insert. Now here we pass in the position and where we want the matrix to append, add the row. So let me just give a print statement to make it more beautiful. So print print row successfully added. Copy it, paste it, so my indentation, and let me just return it at once. Okay, that's it. Then maybe we can also add another matrix that says def delete row. So the person passing the key to the row or the position of the row, and it deletes the row. So self the matrix dot pop position. Well, we can also do the same thing we did for the last one. In case the person doesn't specify the position, we'll just pop off the last row. So we can do that same thing if not not was self the matrix dot pop. So this automatically pops the last row. Return and row delete success. Oh, okay, so I don't want to waste much of our time in the implementation. So this matrix is just going to be a very basic matrix where you can add rows and delete rows. Maybe in future videos we are going to do the one for columns because columns are more complex. And remember, we need our matrices to have a regular dimension, not something where there is in each of the rows, one row has like 3 columns, while the others have two. That's an irregular shape, and that is also, apart from being irregular, it will be hard to manage, it will be hard to do operations on it. So, but it exists though. We'll be implementing things like that in the future, but for this video, we're just going to keep it minimal, where we can add rows and delete rows. Okay, so back to it. Let's create a function for adding rows def. Oh, sorry, I said adding other matrices. So add matrix. So it takes self and it takes the matrix to be added. Let me call it B. Okay, let me call it matrix. And now we are going to do something tricky. First, the first step we take is verify the both matrices are the same dimension. Very important. Very, 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 very important. Now, to do that, we are going to do something. First, we'll create a clone of the matrix property. So we'll call it matrix A. This matrix A, self dot matrix. Matrix B equal to the matrix parameter that we are taking in this method. So then we are going to find out the length, the number of rows and the number of columns in a matrix. Remember what I showed you earlier? Oh, what did I do? Remember what I showed you earlier about matrices? That they are just nested arrays. So let me show you one more time. This is a matrix 1, 2, 3, 4. Now, if you look at it graphically, they even look like that drawing, like that example that I showed you earlier in this video. So this makes a column 1 and 3 are in the same column, 2 and 4 are in the same column. And if you look at it very well, they are just elements of nested arrays. So how do we find out the both matrices have the same dimensions? Simply by finding out the length of the rows and the length of the columns. How do we even do that? So we'll use the structuring to assign the values. Well, I don't want to confuse you anymore further. So we'll create a variable a row length, b row length, and we'll assign them their row length values. Now to get the length of the rows, the number of rows in A, we can do length of A. Remember, look at the example I gave above. To find the number of rows that A has, just do the length of that matrix and it returns the number of rows it has. Now the same thing goes for B. Now, what about the columns? To find the number of rows that A has, we'll repeat the same process, but now we have to dive deeper, take one step further inside the matrix. So A column length, that's what I'll call the variable, B column length, and I'll assign it to get the number of columns. I have to first get a row. From the number of elements in a row, I can tell the number of columns a matrix have. So first that, and then we get the length of that first row. Repeat the same process for B, and voila, we have the length of the columns and the length of the row. Now, to what verifies if the both of them have the same dimensions. So, of course, we'll make up an if condition where you do A row is not, if A row is not equal to B row length, or if B column length is not equal to A column length. Let's raise an exception. Let's say value error. They have invalid, okay, on matching dimensions. Okay, now after that, we want to go straight into the addition. So how do we add matrices? Well, I told you that matrices, the implementation of this matrix in Python is pretty simple. It's just a nested loop. So we are going to, sorry, just a nested array, a multi-dimensional array. So to add two matrices together, that means we are going to use nested loops. And that means we are going to use a time complexity of O n square, which is quadratic, right? That's quadratic. That's a quadratic time complexity. And oh, that's not good. But we have to do it. So for I in range of the A row len, then we have to take it a step further to get each element inside each row. For J in range of B row, or A or B row len, both of them works. But let me still use A. Oh my god. Of A column len. Oh, I forgot to add something. A results array. So let me just put it here. This is where the result matrix will be stored. So let's go. Now we are going to, in each iteration of I, we are going to create the new result row, which will be appended to the result matrix. So row append the new result element, which is A I J plus B I J. Now at the end of that loop, we append the new row to the result matrix. Append and row. So let's test it out. Let's test it out. Okay, after appended, let's return something. Self dot matrix will now be equal to the new matrix. Yeah, self dot matrix is equal to the new matrix, and we'll return self. So we'll return the new matrix object that from that operation. So let's implement test A. equal to matrix. So let me instantiate a 2D matrix. 1, 2, 3, 4. Okay, let me do the same for another the second matrix test. B matrix 3, 5, 6, 5, 6, and 7, 8. Okay, let's go. So print. Okay, let me just create a result matrix. Result test A, add matrix test B. No, one more thing. Since this is so, let me just do matrix dot matrix here. Okay, so let's go. Print results. Okay, so let's run it. Control Shift. Okay, see the matrix is in Python main.py. It returns the result matrix, and not just that, let's see what the output matrix was. The result matrix, the values. So the matrix. You see, it works. Now let's go to the addition, the subtraction of matrices. Well, let me not waste much of your time. Subtraction of matrices is just the same thing as addition of matrices. The only difference is that you're subtracting numbers instead of adding numbers. So it's like the reverse of the addition of matrices. But the rule still holds. Corresponding elements subtract each other, and each matrix must have the same dimension to be able for you to add it. So here's what we did. We copy and pasted the add matrix method, turned it to subtract matrix, and then instead of doing additions inside the row, instead of doing it inside, instead of adding inside the new element that will be appended to the row, we subtract. Now let's test it out. So let's test it out. Swap, subtract, matrix, and here we go. You see, it all goes in minus because matrix A is smaller than matrix B. So all our values are in minus. Wait, this isn't right. This isn't right. We are not adding properly. Why is that? There's an error in this code. Hmm. There's an error in the matrix. So 1 minus, let's calculate manually. 1 minus 5, that's minus 4. 2 minus 6. Oh, there is no error. It's actually correct. Wow, I'm doing wrong. So that's it for addition and subtractions in matrices. On the next video, we'll be looking at sub scalar multiplications and multiplications in matrices. See you on the next one. Wait, before you go, there is another way to implement matrices in Python and do the addition and subtraction. And the bonus, the shocker, the spoiler, I don't even know how to put it. But the thing is simpler and is faster. Okay. It's done with the help of a very special Python library for mathematical operations. Let's get in. So I'll call this sub.py, and this repo will be linked in the description. So don't forget to check it out in case you want to look at the code yourself. So the name of this library is NumPy. So import NumPy as MP. I don't know why we always call it MP. Okay, let me just call it import NumPy as math. Okay, so we can easily implement a matrix in NumPy, and let me show you how. A equal to MP dot array. Oh, I still called it MP math dot array. Let's pass it a simple matrix like the one we gave before now. The 1, 2, 3, 4. Let's do the second matrix, matrix B, and just copy this and paste it here. 3, 5, 6, 8, 7. Okay, now to add two matrices with this numpy, with this library, is very easy. All you just do is print A plus B, and voila, you can just add two matrices together just like that. And what does the magic is that it runs this very fast. I discovered that NumPy uses C, the programming language C, under the hood. So let's just try it out. Um, Control Shift, Control Shift, Central, and I'll get my terminal from here. New terminal. See matrices. And let me switch to this. Hold on. Okay, now Python sub.py. Do you see it? It added the both matrices together just like that. Very easy. In less than 10 lines of code. It's actually 13 lines because of the spacing, but is actually less than that. It's that simple and straightforward. So NumPy uses C under the hood, and it makes it way faster than normal Python than the last implementation we had. So the same thing, quick and easy. So what can I say? Pick your poison. Whichever implementation works better for you, use it. But I would advise you to use the first one. The first one will help you sharpen your skills. Yeah, to help you sharpen your skills, it will help you understand how to implement it yourself and not just depending on these libraries. Okay, that's it for this video. I'll see you on the next one. Don't forget to like, subscribe, and share. But most importantly, don't forget to practice. Peace out.